Our glaciers are melting, reducing the amount of preserved freshwater. The ocean level is rising, overtaking settlements. Global temperature is rising, prevailing extreme weather over the globe. At every moment, 8,000 to 20,000 airplanes will be in the sky. In 2019, the global aviation industry produces 915 million metric tons of carbon dioxide. The aviation industry is one of the industries contributing to global carbon emissions. Necessity is the mother of invention. With a recent breakthrough in battery technology, the electric revolution is getting into the sky. Fully electric planes already took off into the sky for pilot training and short-range flights. This would bring down the cost of the flight because fuel is the major cost for the flight. However, it cannot take a long-haul flight. This is mainly because of battery energy density. Today, commercial battery has an energy density of 250 watt-hour per kilogram. For comparison, jet fuel that operates current airplanes has an energy density of 11,666 watt-hour per kilogram, which is 46 times energy dense than battery today. This is the Siemens powerful all-electric aircraft with a maximum speed of 340 kilometers per hour. It has a 260 kilowatt motor weighing only 50 kilograms. Powerful enough to carry 200 kilograms of payload. There is another company called Pipistrel who manufactured their fully electric aircraft called Alpha Electro. The aircraft is best to suit for short-haul flight and flight training purposes. It can carry 2 passengers including a pilot. Another groundbreaking achievement in electric aircraft is Eviation Alice in Israel. The company manufactured fully electric aircraft with a passenger carrying capacity of 9 passengers and 2 crew. The aircraft is powered by 3 electric motors with a power rating of 260 kilowatts. Having a range of 1,000 kilometers, it can cruise at speed of 444 kilometers per hour. The aircraft has a 900 kilowatt-hour battery with a total takeoff weight of 6,350 kilograms. The aircraft demonstrates that the future for electric aviation is not too far. Recently, Elon Musk tweeted 400 watt-hours per kilogram with high cycle life, produced in volume not just in the lab, is not far. Probably 3 to 4 years. The statement depicts that the electric airplane for long-haul flight is very near. 400 watt-hour per kilogram energy density will be a 60% increase in the current energy density of the battery. Theoretically, the battery could increase the current range of electric aircraft and electric cars by 60%. In other words, it could reduce the price for battery-operated vehicles and aircraft for the same range. Now let us enter into basic engineering calculations and analysis to find out what if we convert the Airbus A320 into a fully electric aircraft. Can we achieve the same range with 400 watt-hours per kilogram battery energy density? Airbus A320 has a full tank fuel capacity of 23,430 liters of kerosene and it weighs 18,838 kilograms with a density of 0.804 kilograms per liter. The full tank fuel has stored energy of 223,963 kilowatt-hours with an energy density of 11,889 watt-hour per kilogram. However, jet engines have an efficiency of about 50%. Therefore, the useful energy in the full tank fuel will be 111,981 kilowatt-hours of energy. For comparison, if the energy density of the battery improves to 400 watt-hours per kilogram, then a battery with the same weight as jet fuel in A320 will have a total energy of 7,535 kilowatt-hours. However, the efficiency of the electric motor is 95%. Therefore, useful energy is 7,158 kilowatt-hour. Replacing two jet engines with an electric motor of the same power will save about 7,500 kilograms of weight for an additional battery. Now total useful energy in the battery will be 10,535 kilowatt-hours. Therefore the plane will have a theoretical range of 578 kilometers. However, we can compromise the passenger carry-on capacity for long-haul flights. Now the conclusion is, for the same weight of Airbus A320, the electric-powered Airbus A320 will have a range that is 10% of the range of fuel-powered aircraft. However, the cost per ticket for the flight will be 3 times less than the current commercial flight ticket for the same distance traveled. Beside fixed-wing, electric vertical takeoff and landing aircraft, also called VTOL for air taxis, are also in process of development by several companies like Airbus, Boeing, Toyota, Uber, EHang and several others. All in all, if battery energy density is increased up to 400 watt-hour per kilogram, then the future of the electric aircraft for long-haul flight and mass passenger transport is not so far. The flight will become much more affordable for average people. This will largely enhance the number of a passenger taking flight as a means of transport between 2 points. Of all, the carbon emission from the aviation can be largely reduced, thus safeguarding our Mother Earth. This brings to the end of the video. This is Science Tech. If you like my video, please do not forget to like, share and subscribe to my channel.